Welcome to Wildcat Science with Mrs. Haugo. This is Chemistry, Chapter 11, Section 2, Part 4. Today we're going to learn about percent yield and concentration. So in chemical reactions, we don't often get 100% of the product. So we want to know the percent yield of a chemical reaction. So please write down this equation. Percent yield equals actual yield over theoretical yield times 100 to make it a percent. Let's write down some notes to help us remember. The actual yield is found in the experiment, and then if it's on a book, if it's in the book and like a problem that you're given, it will often be found in the problem. The theoretical yield is calculated. Now that's going to be a mass-to-mass problem, which you already know how to do. So let's look at how to do this. What are some reasons that actual yield is less than the theoretical yield? Well, one of them is that it is difficult to collect all of the product in pure form. So sometimes you didn't get all of the product, sometimes it's not like pure copper, maybe there were some side reactions and you have some copper oxide, and so now it's not all pure copper. So side reactions that reduce the amount of desired product. So maybe, like I said, some of that copper oxidized with oxygen in the air and got this undesired product because we wanted just copper. Also, there are errors in massing during the reaction. Maybe you didn't quite mass out enough of the reactants or something like that. So let's dive into a percent yield problem. First step, as always, is to write a balanced chemical equation. Okay, the next step is to find the actual yield, which is often in the problem. And then the third step is to find the theoretical yield, which is usually a mass-to-mass problem. And then you use that equation. You divide the actual yield by the theoretical yield to get a decimal and multiply by 100 to get a percent. Okay, let's do it. Please write this down. Melanie heated 10 grams of sodium bicarbonate. After the decomposition reaction was done, she massed 4.87 grams of sodium carbonate. Notice it's bicarbonate versus carbonate. What was her percent yield? She noticed the products also included water vapor and a gas. So we're going to tackle that. Okay, we're getting ready to go. So before we dive in, make sure you have a periodic table and a calculator. So our first step is to figure out what we know. So Melanie heated 10 grams of sodium bicarbonate. After the decomposition reaction was done, she massed 4.87 grams of sodium carbonate. What was her percent yield? All right, so we're going to write down what we know. My bar is a little bit hidden. Okay, what do we know? We know we're trying to find percent yield. And then, what else do we know? We know we have 10 grams of sodium bicarbonate. So we have 10.0 grams, and then you're going to have to come up with the formula of sodium bicarbonate. So if you did sodium and then our bicarbonate ion, NaHCO3, good job. And then we have 4.87 grams of sodium carbonate. 4.87 grams. You have to come up with the formula for sodium carbonate. Remember, carbonate is one of our polyatomic ions, and it's -2. And then sodium is +1, so we're going to need 2 of those. So Na2CO3. Okay. So then we're going to need to write a balanced chemical equation. So you want to figure out what the balanced chemical equation is. Okay, so let's take a look at this. Melanie heated 10 grams of sodium bicarbonate, so we know that that's one of the reactants. After the decomposition reaction was done, she massed 4.87 grams of sodium carbonate. So we know sodium carbonate is one of the products. There's also water vapor and a gas as one of the products. So we're going to start with our sodium bicarbonate. And then we're decomposing it, and we're going to get sodium carbonate. And then it also gave off water vapor and something else. So let's think through this. So if I have 2 sodiums in the products and 1 sodium in the reactants, I know I'm going to need to balance it going with a 2 coefficient. But then for every two sodiums, for every time I double the sodiums, I have 2 carbonates. But in this one, on the product side, I only have 1 carbonate, so I have an extra carbon. And what gas has carbon? Well, how about carbon dioxide? So let's see if that works out. So 2 sodiums, 2 sodiums. Then I have, let's do carbon next, 2 carbons, 1, 2 carbons. And then let's do hydrogens. I have 2 hydrogens, 2 hydrogens on the product. And then I have, let's do oxygen, 6 oxygens. And I have on the product side, 3 plus 1 plus 2, 6. Okay, so it is balanced. Let's think through states of matter. Well, we know carbon dioxide is a gas. It talked about water vapor, which is a gas. Now let's think through the next 2. So sodium bicarbonate and sodium carbonate are ionic compounds, so they are either solid or aqueous. And it says it's a decomposition reaction. And we know decomposition reactions often happen in solid state. So sodium bicarbonate is baking soda, and we know baking soda is solid. And then over here it's a little bit tricky because there's water, but it's not liquid water, it's water vapor. So the sodium carbonate is going to stay solid. Alright, so the next step is to figure out what the actual yield is, and it's often in the problem. So let's go back, and we know it's going to be sodium carbonate. It's right here, 4.87 grams of sodium carbonate. So actual yield equals 4.87 grams. Let's write down what we're dealing with. Sodium carbonate. Then we're going to find the theoretical yield, which is usually a mass-to-mass problem. So when we do a mass-to-mass problem, first thing we do is write a balanced chemical equation. Done. And then we have to find the molar mass of the known. So our known is going to be our sodium bicarbonate, what we're starting with. So our sodium bicarbonate is going to be 1 mole of sodium bicarbonate over its molar mass. So take a moment and find the molar mass of sodium bicarbonate. Did you find that it is 84.01 grams? If so, good job. Now find the mole ratio with our unknown. What are we going for? Well, that's the product here. So the product is sodium carbonate, and it's our unknown, even though we have an actual yield, because in our mass-to-mass problem, we don't know the theoretical yield yet. So our unknown is, well, let's look at the 1 mole of sodium carbonate. 1 mole sodium carbonate over how many moles of our known quantity, which our known quantity is the sodium bicarbonate, which in our balanced chemical equation is 2 moles. 2 moles sodium bicarbonate. Then we're going to find the molar mass of the unknown. So our unknown, as we know, it's what we're going for, the theoretical yield of sodium carbonate. So 1 mole sodium carbonate, and then we might have to flip this around, find its molar mass. Okay, did you find 105.99 grams? If so, good job. Next thing we're going to do is set up the problem and calculate. So if you remember, for a mass-to-mass problem, we put our mass of our known, which we go all the way back up here, is 10 grams of sodium bicarbonate. Okay, so we're going to have 10 grams of sodium bicarbonate, and we're going to put our original quantity over 1 times our molar mass. So we're going to have, we want grams to be on the bottom, so 1 mole sodium carbonate on the top, and then our molar mass, which is 84.01 grams. And then that is sodium bicarbonate times our mole ratio. And we want to cancel out sodium bicarbonate. So let's see, sodium bicarbonate is 2. Looking at our, yep, sodium bicarbonate is 2 moles. Sodium bicarbonate on the bottom, so it cancels out. And then it was 1 mole of sodium carbonate on the top. Then we're going to look at the molar mass of our unknown, which is our sodium carbonate. So we want to cancel out moles, so I'll put 1 mole sodium carbonate over the number of grams, which is 105.99. Sodium carbonate. Then we want to plug and chug. We want to check first, then we'll plug and chug. So gram sodium bicarbonate cancels with gram sodium bicarbonate. Mole sodium bicarbonate cancels with mole sodium bicarbonate. Mole sodium carbonate cancels with moles sodium carbonate. We're left with grams sodium carbonate, which is what we want. Now we can plug and chug. Okay, hopefully you have the answer. And I got 6.308177. And we're going to talk about sig figs again. Going up to our original quantities, 10.0 has 3 sig figs. 4.87 has 3 sig figs. So my answer to 3 sig figs should be 6.31 grams sodium carbonate. Okay, great. Whew, we got our theoretical mass. We're done. No. Remember, we're trying to get our percent yield. So we're going to write out our equation. And I'm going to combine these 2 steps to just get our percent yield. So we write percent yield equals actual yield over theoretical yield times 100. All right, then we're going to plug in our numbers. Okay, if you remember, our actual yield was way up here in the problem, 4.87 grams. 4.87 grams, and our theoretical yield was what we just figured out, 6.31 grams divided by 6.31 grams times 100. I'm going to pause there, and you need to figure out the percent yield. See you later.